Good morning, everybody. Hooray! Hello, Andrew. Give this man a prize for being awake. Hi, everyone. Thanks for coming to today's tutorial. We're recording this on Zoom. There's a link in the classroom channel on if you want to see this screen on your own laptop. I'm going to talk a little bit about forms and a little bit more about some React layout tools and things like that. Quickly talk about some debugging. I'm sure you've hit a few bugs and testing generally. And if anybody shouts out a topic right now, I will add it to the list. Anything else that you're interested in learning a bit more about or you've got stuck on? Okay, right, well, we'll dive straight in with this. So, let's look at some forms. So I went back to the template and I installed one of the many available React form libraries that you can pick up on. There are some that are very popular, but there are also some that are embedded in the slightly older way of doing React with components and stuff like that. So I've decided to try out in this example here a modern forms library, very simple forms library that is based on using React hooks. And where did I put it? So if I look at the application, so I've added a form to my index page here, and it basically is going to do exactly the same thing as this button, but it's also going to collect some data at the same time. So I could put in a value like 77 and a comment like hello, and I could submit that. And you'll notice I'm still not getting any feedback from these forms to say, hey, Andrew, you succeeded in doing this thing. So that's another thing to look at. And then in the report, and one of the things we're going to look at in a minute is why this report takes 10 seconds to come on the screen. You'll see that I've updated the output here so that you can see if there's a value and a comment that they're printed out. And I've also, we'll take a look at how we can make this output look a bit more attractive by using some of the styling components and things that we have available. So, how are we going to do this form? So forms are really important. Almost anything you're doing with a website design that isn't just presenting information to the person means that you're going to try and collect information from the person, either directly or through calls to the environment on their browser or mobile phone and things like that. And so having collected it, you usually have to do a few things. One is inform them what you're trying to collect. Then validate whether the stuff they've typed in makes sense or not. So if you're expecting numbers, whether they've typed in numbers. And then you just have to deliver that information back up to the server. And in the good old traditional web HTML pure way, what you would do is the browser would create the form. And it would automatically, when you hit the submit button, it would do a post request with the form contents already either in the body or in the URL, depending on how you set it up. And then your server would just get this result back, and then it would regenerate a new page and it would send it down. And that works actually pretty well, and there's no reason to not carry on doing that. But in a sort of more single page application, component-oriented world, we don't see the point in sending a form and then just waiting for a whole new page to come back when we could just keep the page we've got. And when you click the submit button, just send an AJAX request or an XHR request. It says, here's just update this API with these new values. Okay, so here's the index page, and you can see all I've really added is a new component called event form. And if we go and look at that, this is in the components folder. And so it is a pure standard React component. And I've imported another hook called useForm from a library React hook form. So if you wanted to incorporate this into your application, you would just do npm install React hook form. You take a quick look at the documentation to find out how it worked, and then do what I did, which is cut and paste the examples. Isn't this how all coded developments work? So, so to use the form, we like all these hooks, there should be the first thing you call in the function, and which just calls useForm, and it returns us two tools. One is called register, and one is called handle submit. And there are a few other bits and pieces that we can use for validation, but unfortunately, I've not had time to add the validation parts to the example. So you can do that as homework. And so then the next thing we have to do is define the form. And unlike some other ways of doing it, so voluntarily we were using a component library called Atom that comes from Alibaba, which is really nice. It's got a whole bunch of nice buttons and layout tools and things like that in it. But it does forms, and that means that every component on the form is a special component. It's a special sort of input or a slider and things like that. But if you don't need that, then you shouldn't do that. If you can get away with writing as much standard HTML as possible, you should do so, okay? So because the basic HTML is fine for most applications, it works fine, and you can obviously still override styles and things like that. So here we have form, and we have label, and we have input. And in these two examples, we're just collecting text inputs, but these could easily be password inputs or numeric inputs and things like that. And the only difference between this and a traditional form is, first of all, we're using the Tailwind's classes to just make it look pretty. And so this is essentially saying my form is a maximum width for a small screen. So it's essentially like a few inches across, background white with a medium shadow, rounded corners, and a padding of 8 and a padding, basically padding between the text lines of 6 and things like that. So I don't know all of those codes just yet, but anyway, the upshot of all that is to give us this nicely, the label here, the spacing, the panel, and everything else. And I just changed the background color of my main page here, because if you're going to use panels, then they should stand up against something. So the input themselves, every input needs a name. That's a rule, whether you're using forms or pure HTML. And you can obviously style it. And then the only bit that's really been added is we're using this register function that we got from the form definition, use form here. And we're adding it as a ref here. And that's essentially binding, linking the working with this input to whatever this function does. And I don't really care. It works as a black box and it seems to work fine. Essentially what's happening is that when you are typing into that box, it's collecting the keys, making it and effectively calling an on change every time and then pushing it into local state that's hidden inside the use form, so that you don't have to create, you don't have to have use state to define a field to hold your values in, and you then do on change handlers for each element so that you can write the changed values into your local state. So that's how you would probably end up doing it if you were hand rolling it. So the only other thing that's left to do on the form is a submit button. So it's a standard submit button. We're using a top level class, which gives me those blue buttons. And we're not even, you can't see an on click handler for this button here. It is a proper form button, and the handle submit is up on the form definition here. And we are going through the handle submit that useForm gave us, and then we're passing in our own handle submit. So this is saying, once the form's submitted, collect all the properties together that we're interested in, and then pass them back onto onSubmit, which is my function here. And that's being passed a data object, which is just literally all the names of the fields and all the values of the fields. It couldn't be easier, and it's taken longer to explain than to actually do. I'm then just creating an event object and then calling log event a log event. So if you compared it to the code that we had yesterday, I've simply factored out the post request to send events up to the collection on the database so that I can use it in the original button that we had and in the form example. And that's all there is to forms. There's, if you go and look at the documentation, you'll see how to add validation rules saying this is a required field or this field must match a certain string spec and things like that. But it's pretty straightforward. Any questions about forms? Nope. Keep going then. Let's take a look at the report page here. So, as I said before, this original report was very ugly. It was just literally a table dump of the response back from the server. And so I've done a couple of things here. One is I've converted the date stamps into a time frame, and I'll show you how we're doing that. And the other is then I've converted the table into a grid of panels, and we'll have a quick look at how that's been done. So first of all, we're looking at the events table. Here we've installed another library called Moment. If you're doing anything with dates and times, install Moment. It's so much easier to use than pure JavaScript date time functions. They're especially while you can do basic stuff straight easily enough, it's often very hard to get time zones right and internationalization and things like that. So if your app is likely to be used outside of New Zealand, or even if you're trying to set a calendar event for one person in one country for another person in another country, you're going to need to use an international standard format for dates and times, and you're going to want to be able to use a library like this so that when you talk about lunchtime tomorrow, everybody's agreed on what that means. We're only using Moment for a minimum function, which is just to say, how long ago was the button clicked? And so instead of a date and time, we're just saying 10 hours ago, 8 minutes ago, and things like that, which is what you might do if it was like tweets and postings on a list. You don't really care that it was posted at 6 p.m. on the 31st of July. You care that it was posted yesterday or a few days ago, things like that. So that's all there is for a moment. A very useful library. Just looking at the table itself, this is a common idiom that you'll see. Our function object, our component is returning an outer table with a table body. We're not doing a table heading. And then you're calling map on the events array. So you'll see this pattern all over the place in React, whenever you've got a whole list of things that you want to display. And then inside this map, you could literally do the HTML that you want to spit out, but again, I would say it's very good practice to factor out the component that represents a row or an individual item that you're trying to print. So we pulled that out into event item here, because you can see here that event item is very clean, has no choices in it, and therefore is almost impossible to get wrong. So once this component spits out the right results from a test event, then you know it's right and you can forget about it. One of a gotcha that you should watch out for, though, is in using React, if you iterate across any collection, whether it's an object or an array, and you spit out more than one copy of the same component, which is exactly what we're doing here, you must put in a key. That's if your IDE or linter will remind you if you haven't done that. But if you don't put in a key, then strange stuff happens. And the key needs to be unique across the array. So you can either use the array index, that's perfectly reasonable, or a value that you know is unique across the array. So in this case, we're using the event ID. But that still prints a table, and like, who uses tables nowadays? So this is an alternative view. This is an event. It's still called in my file event table. Actually, should be renamed event grid. So a grid we're going to use. There's modern CSS3 basically gives us two different ways of handling positioning on the pages. One is grid and the other is flex. Grid is essentially if you want to have basically think of the page as a matrix. So you've got rows and columns and you want to be able to place things like you might if they were cells on a spreadsheet, for example. Then you should be using grid. But if you're actually wanting something more lightweight than that, that says, I've got 100 items, just go 4 across and then just wrap and do the next line and the next line and the next line and things like that, then you should be using flex. Flex is flexible, I guess is the only thing about it. It allows you to control positioning, but basically says go along and then go down, or go down and then go along, and position your objects accordingly to how big they are and things like that. So it's in a way it's obscure if you try and read the spec, but in a way it's also pretty intuitive if you just use it. What this one is doing, so we're wrapping the outer object in a div with the flex and flex wrap styles classes from Tailwinds. But flex is essentially flex. Then we're mapping through the event list the same way we were before, but instead of putting in table rows, we're creating a div. We still need a key because we're inside a loop. And we're just using a class name that is saying how big this little div should be. And so, and what we're seeing in Tailwinds here, these keys before the colon are classes that are based on the size of the screen. So Tailwinds is giving us some media queries built in, small, medium, large, extra large, and so on. And we're saying here that if it's a small screen, then the width is half the screen, which means you'll get 2 cells per screen. So if I fold this down, you get to this. If you get down to nothing, then there's only 1. And so we get like that. And so it's these items here that are saying, if it's wide, then we'll get 6 across the screen. And after that, we'll stop expanding. So these two divs are basically handling the entire layout. And as long as event item, and then event item is whatever event item is, which in this case is another panel, a bit like the profile card. So we're using the same, I want a box with some rounded corners and a shadow, and then I want to position the items in there. So we get something like this. And one of the things you can see the difference between grid and flex is that this is when we've got more data, and I'm not clipping this at all, then the box gets quite big and it forces the next row down. Whereas if this was grid, it would, actually I'm confusing myself here. One of them would start to stack them in the remaining space here. Okay, let's go. Any questions about that sort of stuff? No? Let's look at the, let's go into a little on the tests. Now, tests are not mandatory for winning this competition or the hackathon. Okay, we decided we wouldn't be downgrading you if you weren't putting tests in the stuff. But if you have tests, I might look favorably, more favorably on your tech stack. Let's look at a component test. So there are, when you're doing tests, you need two basic things with React. One is that you need a test runner. That's a wrapper tool that's going to find all your test files and execute them and do them in an environment that each one can run in isolation, and then has a bunch of things that will say whether the test passed or failed or not. So basically it runs test files and makes assertions. Involuntarily, we use the test runner called Ava, which is very nice and very fast. But Jest is probably the #1 thing that people are using nowadays, or at least it's the first one people are using until they work out why they would want to change. And so this little template comes with Jest in, and Jest is a generic JavaScript test runner, which means it's not React specific. It will run anything you write if you've got Gatsby or any Go or any of those. But we're using React components, and we want to be able to talk about the page and the components on the page using React-like language. And so we need something that will load a React component. And the library that we're using for that is called Enzyme, which comes from Twitter, I think. All the good libraries come from somebody who's put in a lot of money for them. And so let's look at a test. So, so the describe and it are just outer functions that say this is a test essentially. And the first property here is just a string that gets printed if it's going to fail or pass. And the tests almost always then take a function, and this is the test itself. And usually you can pass into a test you can do initial setup, and after the tests are run, you can do tear down. And you can have setup functions that run before every test so that you can make sure every test runs in a unique environment and cleans up afterwards if you've created objects or things like that. But these tests are so simple, we don't have any of that. What we're doing is we're creating a fake user. So one of the things you'll see in tests is you have to remember in tests that the rest of the system isn't there. We're only testing the piece of code that you've loaded, and we're running this module profile card on its own. So there's no server, there's no page, there's no router, there's nothing. Okay, so we just have to give the component everything it would expect to be given when it was running in the real world. And so we're lying about it's basically a head in a jar as far as the component's concerned. So we're using, Enzyme gives us a couple of functions, one called mount, another one called shallow. And I'm not going to go into the details of those, but shallow is faster. But if you've got interactivity in your component, then so like button clicks and things like that, then you should be using mount. And if you use mount, and it doesn't really matter if you use them all the time. What you're going to give to mount is the HTML or the component usage that you're expecting to test. So your component might take no parameters or multiple properties, and it may or may not need children and all the rest of it. So this is the point at which you set up an example of what how your component gets used. In fact, several examples. If we look at the hello test here, we've got 3 examples. One using mounting greet, one mounting hello with the name of testy, and one mounting hello with the name of a variable. So tests are important for a lot of reasons, but here's a couple. First of all, they demonstrate how your components are supposed to be used. So as well as actually finding bugs in your components, the first thing the test is doing is saying, this is what this component does. This is how you use it. If you can call it with a person, or you can call it with no person, or you can call it with 5 people, and it will do different things. And then you can demonstrate in the test what it actually does. So tests in a way become part of the documentation. And if you have a lot of components in your system with no test coverage, then the developers, any other developer that are using them are relying on inspecting the code or finding somewhere else in the code where it gets used in order to understand how your component gets used. And that may mean that you actually haven't demonstrated that your component has certain functionality. So for example, if your component gets passed, so if your component's expecting to be given a user and it's going to print the user's name, if you don't pass in a user, or you pass in an undefined user to your component, it's going to break. It's going to have a runtime failure at the point it tries to dereference the user and print the name. And you won't find out about it until it tries to appear on a screen in someone's browser, unless you're running a test. And you have to basically pass in both a valid user and an invalid user to find out if your component is broken or not. Okay. So the other thing that's they're useful for is is to find out what the component actually spits out when you generate it without having to go to the trouble of loading up a whole set of pages. So the wrapper that's returned by Enzyme after using mount has a couple of functions on it, a .debug function, which essentially converts the whole thing to a printable string. And then you can just log that. And I think if we run the tests, if we just do this, so we get empty on the test, you'll see that, okay, that's interesting. I've got a couple of test failures because I haven't checked the tests for a while. Quite a lot of failures here. And we've got a couple, this one, the profile card and the test component, we can see we're logging the HTML that gets printed out. Actually, we're not, if you use .html, you'll log the HTML that gets generated. But if you use .debug, what you'll do is you'll get a mix of HTML and components. So the React component. So we still think of this as a profile card, even though by the time the browser sees it, it's a div. Okay. The reason I've got this test error here is because this test used to work, but yesterday, as part of a demo, I changed the code. And actually, we'll take a look at that as well in layout and header. Okay. So one of the participants was wanting to make the menu here change color to show which page you were on. It's a fairly, you know, the normal thing that you'd hope a menu would do, and you can see here now that when I click on it, it's going blue, or at least it would if the server was running. And if you're used to jQuery, or you're used to a slightly older style of using JavaScript, the way you might think this is supposed to be done is to say, when the button is clicked, capture that state change and store it somewhere, and then change the class of the component. So basically, when you click about, we find the about button and we change the class to be active so that we know then we draw it as blue if the style is active. And then when we click on home, we change the class in the DOM to be active, and we have to make the other one inactive so that we don't have two blue buttons and things like that. So this is procedural, and it means that you often you have to be able to do an element lookup to find the component you're talking about, and it has this habit of breaking when somebody does like a hard reload of the page, because the class setting that you were doing, which was dependent on a click, is the click hasn't happened now. You've just got a fresh reload of the page. So the React style programming way of doing this is to say, when the component draws, it should try to work out how it should be drawn itself. It shouldn't wait to be told that you should be active and you should be not active. You should be able to work out if I should be active. And so here's the change in the code. So we've got this menu item. It used to just print this link and didn't do anything else. We're now using a hook called useRouter, which comes from the next router, which is similar to the React router. It just gives me an internal object here that I can query for the path, which is basically the URL the page I'm on. So if the path here is matching the href, and the href is the property that's being passed in when I define the menu item as being /about or /report. Then, so if the current path I'm on matches the name of the button I'm on, then then my button should be active, and I can return here the class name for the item is either the active class or the inactive class, and I just pulled out these two strings so that they weren't so messy and changed the orange to blue. But you could change the entire styling. And so this button now displays a different color depending on whether it's active or inactive, and it decides whether it's inactive or inactive by personally checking the state, whether the state's in some state variable or whether it's something it can obtain from the environment, like a request for the path. And obviously it makes sense. If you are you can only be active if your path matches your link. And this doesn't break. If I've got a page that doesn't have not help, we don't have a help page, but we have a hello page. So if I have a page that isn't on the menu, then none of them should be blue, and it shouldn't matter whether you were clicked on this. So some of the things when you're testing pages to watch out for, because the way React helps you build single page applications and you can click around without making extra server trips and things like that. You can sometimes forget that the pages are also bookmarkable and people might visit them directly. So they don't always get to the page the way you think they're going to get to the page, like from the home page. You can be on the results page, and then you might just do might have bookmarked that and then revisited it in a different browser on a different day. So each page has to stand, if it needs to know what the local environment and setup is, it has to work it out at the time or be told it by the server. Okay, just a last couple of things on debugging. Now, first of all, you can actually use a true debugger because we're at least on the server side, we're running Node, which is just a JavaScript application. And so we can go into Visual Studio Code, for example, and where has it gone? Down here. Yeah, and start running the program. And I'm not going to do this live because I haven't tested it, but you can effectively put a bookmark on any of the server-side code that you're expecting to be hit, and you should be able to run to it. I'll check it and maybe demonstrate that later. But you can go to here, like the database loader, and click on that, and then see whether we hit it. But I noticed that most developers don't do that, and even I don't do that very often. It's not often that a problem is so obscure that you have to walk to it in the debugger. So surprisingly, I would say 90% of debugging happens with console log statements. And unit tests, because if you're using a unit test, you can isolate down the code to the bit that's interesting, and then with a few log statements and the fact that you can do quite a lot of inspection of the state from the browser down here. So as I said before, you can look at the component and you can find out what the style is, and you can find out what properties it's being given and things like that. That's pretty useful. Just to note though, console log statements don't always appear where you think they're going to appear, especially when you're using Next. So in order to demonstrate this, I noticed, I commented yesterday that the events page was taking an inordinate long time to load. It takes about 10 seconds. And I was wondering why that was, because I know it doesn't take 10 seconds to get a couple of hundred lines of events. Also, you can notice that it doesn't take 10 seconds the second time you load the page. It's pretty fast. So you hit it twice in a row, and then it obviously seems to have a problem with it. Okay, what's going on? Yeah. Right. If you put console log statements in the code, if they're run at the server side, then they're going to appear here in the terminal where you started the application. And what I've done is I've added a couple of trace. I've used console time, which it starts and ends a timer and just prints out how long it took between the two labeled points, which is also useful. Because I was trying to work out, I wanted to see if it was the connection string, the initial connection to Mongo that was taking the time, as opposed to the getting the data out. And yes, the delay is in setting up the initial connection to the remote Mongo. Which if you had to do it every single time you make a request, that would be bad. But as I can see here, here we go. The page isn't always resetting up the connection to the database. It's often already being cached. And here I'm actually, one last thing I'm going to talk about is the difference between dev mode and the actual production mode of these applications. As a convenience for me, every time I put a change in the editor here, it's going to try and reload that into the page immediately. So if I'm making changes to client-side code, so that's any of the components that are appearing on pages, I don't want to have to even restart stuff. I just want it to appear on the screen so I can immediately see what's going on. But the negative side effect of that is if I make a change to the server side or one of these middleware things, then that module is being recompiled, and that means that any cached information that was there is going to be thrown away, which means that the database connection is going to get torn down and has to be re-established and things like that. So any benefits of underlying caching or optimization, you're not really going to get those while you're running in dev mode. So one of the alternatives, but it's very convenient to run in dev mode. But ultimately you're going to ship this, and so you're going to want to run it in production mode. And there are two lines that you need to be doing when you're running that. So first one is npm build, run build. And that's basically running next build. And this basically goes through all the pages and compiles them. Now remember that JavaScript is not a compiled language. JavaScript is an interpreted language, and you can just throw JavaScript into a browser and run it there and then, and you'll never find out that you had a bad line of code in there until it actually hits it. But what we're actually doing here is transpiling the code. We're building we're doing all the parsing, we're doing all the Babel, we're making sure that everything's right. We're building these pre-prepared downloadable pages from Next. And if they include data that calls and things like that, they may be already incorporated. And this little output here will tell me whether the page I've generated, so the About page, for example, where's the About page? Here, yeah. It's completely static. So all of any of the reactive stuff I was using on the About page doesn't have to, the JavaScript that it represents doesn't have to be run. I've converted it to a pure HTML page, and the server is immediately going to send that HTML page. There is no overhead. It's essentially as if I'd handcrafted the HTML. So if you're like static website generators like Jekyll or Gatsby and things like that, then you can do the same thing using this pattern here. If you just write pages that don't have any get datas or anything, or when they're set up, then they can be pre-generated and they're static. And you can push them to a CDN or serverless and some host, and then just run it. So if your entire site ends up being static, then you can just put it on GitHub Pages and it's ready to roll. I think my own website, grow.nz, is a React application, although there's no actually interesting React components in it. I'm just using it as a static website generator. You can also see which pages are using server-side rendering, and also we don't have any, but whether there's any get static props ones. So having done that, we can do npm start. This is what you'd load into. This is what you'd tell your Docker container or your deployed asset on Netlify or whatever. This is actually what gets run. It comes up just the same, and the only difference is that it's actually running on a different port for me. Oops, not that one. Okay, and when I click to the report here, I'm getting a failure. I'm getting a cause failure. Okay, that's because the port number changed, and so I haven't told my authorization server that I can work off this one. Damn it, the demo. Other than that, it would be really fast. As you can see here, this page comes up really fast. All right, any questions? I'm gonna let you go back to, you're all really keen on your projects, I can see. So I'm going to be here, I'm just going to be here, and so bring, as running a clinic, so if you get stuck in React or if you get stuck on the database side, just come and, ask your mentors, but I'm here as well to give help. I'm enjoying the whole project. Thank you very much.